Welcome back everyone. My name is Sagar and in this video we will be learning everything about map and set in Java. And we are going to learn about all these things in this one video because these things are interrelated. We are going to use set, we are going to use map inside of our set, and inside of our map we are internally using this hash code and equals. So we will also learn about that. So first of all, let us just start with map. So map is our interface in Java, and as you can see here, if we have this dotted line, that means there is gonna be a implementation to our interface. So this hash map is a class that is implementing our map interface. So there are basically three kind of map classes that we have in Java. So first one is this hash map, then this linked hash map, and also this tree map. But we also have one enum map, and I never use that in my whole programming journey. So you can just skip that part. So the very important thing is this hash map. So you are going to use this very extensively in your programming journey. So we are going to focus on this thing, and we can also learn about this link hash map and also this tree map. So this tree map is a class that is implementing this navigable map interface, and this interface is extending this interface. So you can just consider this hierarchy. And one of the main question for your interview is going to be the internal working of hash map. So we are also going to learn about that. So let us just create a hash map and let us see what it is. So you can just create a map here. So inside our map we have to use this generics, and we already know how we can use this generic. So suppose for our array list we can just pass here one type, suppose integer type. So we can just pass here one type. But for our map, remember that thing, map is a different kind of data structure that stores unique key value pairs. So here it takes two parameters. So all the other data structure take only one parameter here, that means one type here, but map takes two. That means we have to first of all define here a key. So suppose key is a string and value is integer, like this. So let me just import this map interface, and I can just define here a map, new hash map. So I am creating the object of this map with this hash map. Okay, so this hash map is a class, and I am creating the object of a hash map here. So here you can see we are passing. So here you can see we are passing here two values. First of all, this string, that means our key is going to be this string value, and the second one is this integer, that means the value of our string key will be this integer value. Okay, so it will be like suppose for an example, so suppose I am writing here Sagar. So it is a string value, that is a key, and there will be a corresponding integer value with this attached to this string value. So for Sagar it is 1, suppose for Java it is here 10, for DSA suppose it is 100. So it will store some values like this, and let me just show you map dot put. So there is a put method inside of our map using which we can just pass here two values. So here inside of this map put method, here you can see we have this put, and it also returns a v type. So v is this value. Okay, so we have this key and this value, so we have to pass here two parameters. So first of all, suppose key is Sagar and then value is 1, and we can just do the same thing Java DSA 10 and 100. So let me just try to print this map here, and now here you can see it is storing values like this, but it is not in the same order as I am inserting them. So the first value that I am inserting is Sagar and 1, and here you can see the first value is here Java. So what is this problem? This is not actually a problem, but it is the unique property of map. It is actually the unique property of our hash map, because hash map internally uses this thing. So let me just show you. So you can just check this hash map class, and at the very top here you can see, so it internally uses this hash table. So hash table based implementation of map interface, and here we will be using this hash code method from our object class. So we will also learn about that, how this works internally. So first of all, let me just tell you about the unique property of this hash map, that it stores these unique key values. So suppose I am adding this Sagar here one time, but suppose after this I am adding this Sagar again. So Sagar, but this time the value is going to be 20. So now this time what it will do, so in other data structure what will happen? So first of all, this value will also remain in our data structure and all these value also, but when I am adding some different value, so this will be a new value. But for our map, there will be no new value created for our map, and now this value will be just replaced, because for our key all keys will be unique inside of our map. And for this Sagar key, first the value was 1, but this time we have this same key Sagar, so this time we are going to replace this one value with this new value 20. And as you can also hover here and you can see duplicate map key, so you can see these are the same keys, but this time we are going to get this 20 value. So let me just check it. So again, we are going to get some random values, random order inside of our keys. So first of all, Java, then DSA, and then Sagar equal to 20. So if you are adding multiple values like this, and at last you are adding this 10, so it will update all this value again and again, and at last we are going to get this 10 value. So only this Sagar key will remain one time inside of our map. And as you can see here, so I hope now you understand the unique nature of our map, and now let me just show you how it works internally. So first, I hope you analyze the use of this map, that you can just map some value with some another value. So suppose you have some unique values like 1 will have this A, 2 will have this B, 3 will have this C. So you can just map some values like this. Suppose you have some problem where you have to map some values with each other, so that time you can just use this hash map. And if you have some duplicate values, suppose like 3 is gonna be Z, so you can also update this. And first let me also show you some more methods. So suppose I want to get the value of this Sagar, so I can just use this map.get, and here I have to pass the key. So I know the string is our key, so I can just use this value and I can print it out. So this time I will get the value as 1, because here I will just say I have to get the value of this key, so there will be a value associated to this key. And suppose I am passing some random key that is not present inside of my map, so this will just return me nothing. As you can see, this time it is returning me a null value. And this is not because we are passing here this string, but instead you can just pass here some random value, and it will always return you a null, because it will just check that this key is not present inside of our map. So we are gonna return a null integer value. Okay, so this is an integer class, so that's why it can be null. Okay, now let me explore more methods. So map dot, so here this put get, and there is this hash code method, is empty method. That means either we have any keys inside of our map or not. And this key set, so this will just return us a set of all the keys, so you can also print it out. So this will return us a set data structure that we will learn in this video itself. So it will just return us Sagar, Java, and DSA. Here you can see. And now after this we have this size method that will tell us how many elements are present inside of map. And this clear method, and you can also explore these method by yourself, but I am going to show you all the important ones. So this contains key, so it will just return us a boolean value whether a key is present inside of our map or not. And also this contains value. And there is this entry set, so it will just return us a set of entry. That means it will just return us a set of key value pairs. Okay, so after this we have this get or default, so this is also important method that you will be using. And we also have this put if absent, so I think this is also important one. So I will only put anything inside of my map if that thing is absent. So suppose I am doing this thing, Sagar 100. So what will happen this time? So first of all, I am adding this value as Sagar 1. So now that time Sagar is present inside of my map. And here in this line, what I am doing, I am checking, I am only putting the value if that is absent. So if Sagar key is absent inside of map, then only I will insert this value. But I know that Sagar key is already present, so now this value is not going to change. But suppose I am adding some random value, so XYZ and 10. So now this time put if absent. So now this time we are going to put this value inside of our map, because now this value is not present inside of my map previously. So I will just print the map here, and this time the Sagar value will not updated, because obviously it was already present. Here you can see Sagar value is already 1. and I hope you can just explore all the methods by yourself. And after this hash map, we also have our linked hash map. So this linked hash map, so it is nothing, just a class that is extending our hash map, and it is also internally using our linked list. So why it is using our linked list? Because it have to store the order of the insertion. Okay, so here you can just read this java docs, and remember that thing, you cannot learn everything from watching some videos on YouTube. You have to be a good developer. You have to understand all the things by reading blogs, or by reading some docs that are present. So don't just totally rely on watching YouTube videos or some courses. You have to learn everything by yourself. So just be comfortable in reading these docs. So here you can just read hash table and linked list implementation of map interface. And this internally this maintains a doubly linked list, and it also stores the insertion order. Okay, so if I am inserting these values, Sagar, Java, and DSA, so it will only return me these value in the same order. As you can see, Sagar, Java, and DSA. But if I'm using here hash map, that will only use hashing inside of it, and it will not return me the same order. So here you can also see the benefit that I am just using here map interface, and I can just change the implementation. Either I can directly use a hash map, or I can use a link hash map, or I can even use a enum map, not enum hash map. So here this is just a map for our enum values, so you can totally ignore this. I never use that in my entire journey. So after this linked hash map, we also have our tree map. So this is a tree map implementation that internally uses our special kind of tree, that is a red black tree. So we will also learn about trees in our upcoming videos. So if you read these docs, then you will find that this is a kind of map that store its keys in sorting order. So if I am adding these values, so this will just follow a dictionary order. That means first of all DSA, because it starts with D, then this Java, and this Sagar. So it will just store this value in sorted order. Here you can see this is the same order, and remember this thing that only keys will be unique inside of your map, and if you are adding these values, so all these values are same, so there will be nothing different for our map. Here you can see. So now you know all the methods and all the type of map that we have. So now let me just tell you about the internal working of our hash map, how it store unique values. So only about this hash map, and here let me just show you how it works internally. So it is also here using a load balancer, that you can see the value of its load balancer is 0.75. That means if the capacity is 75% filled, then it will just double the size. And here you can also see initial size is 16. So if you have already watched our array list or a string buffer or string builder video, then you know what I'm talking about. So here it will have some initial size, and if the 75% is filled, then it will just increase the size automatically. And how can we find the hash code of any key value entry inside of our hash map? Using our hash code method, that is from our object class, but it is implemented, it is overridden in every single class, because every class is just a children of object class. So here you can see inside of this hash code method. So here it is, as you can see here. So first we are finding the hash code of a key that we are using inside of our hash map entry, and after that we are using the XOR operator with hash code of value. So that's how we are going to find a unique hash code for each key value pair inside of our hash map. And as you can see here, so here we are adding the entry as Sagar as key and one as value. So first of all we are going to find the hash code of Sagar. So Sagar is a string value, and we are going to see how hash code method of string is implemented. So there is a unique computation for hash code of string, and after that we will find the hash code of this integer. So integer is also a wrapper class for our int data type, and a hash code method is also implemented for our all wrapper classes. So now let me just show you how this hash code method works. So first of all, we will have a string that will be Sagar. So let me just create a string object and show you how we can find the hash code. So string s equal to Sagar, and s dot. So now this s is a string object, and now we can access the hash code method, and let me just print it. So as you can see, this is the hash code unique integer value for our Sagar object. So this is a Sagar string object, and we are gonna use this unique integer value and XOR it with 1, because 1 is the value of this key. So this is how internally string hash code method is implemented. So it is using here string Latin or UTF class, but it is not that important that you have to understand internal working. So here you can just see, so this is the proper computation that we are using to find the hash code of string. So as 0, that means the first character, multiply by 31. So 31 is just a unique prime number, and after that we have this XOR operator, but here it is not an XOR operator, it is here exponentiation, and that means 31 to the power n minus 1, and n is the size of our string. So after that we are adding here s1, that means first character, into 31 to the power n minus 2, and so on. So here you can see this operator indicates our exponentiation, that means power. So every time when we are using this method, it will just return us a unique integer value. And if we are creating any class, so every class is just a children of our object class. And if any class is a children of object class, then it can have methods like hash code and equals. Remember that thing, there is a possibility that two objects can have a same hash code, but it is not necessary. If they have the same hash code, they are equal. That totally depends on your internal implementation of hash code method, whether they can have equal hash code or not. So here is our pair class, and this is a children of our object class, so it will have a hash code method. So here you can see it is from object class, and also equals method, and there are some more methods here. But here we are not overriding any hash code or equals method, so there is a possibility that two objects of our pair class can have a same hash code. So let me just show you by example what happens if this Sagar returns an integer object, and there is another object that will return us the same integer value. So first of all, we are gonna store it in an array, and initially the size of our array will be 16, and we are gonna store according to their hash code. So suppose there is a key that have the hash code as 0. So that will be stored at index 0. So we are going to store the entry, that means the key and value both at index 0. And if someone have the hash code of 1, so we are going to store it at 1 index. So there will be a whole linked list at every index. And how we are going to implement the linked list? So first of all, we are going to add the first key value pair, that means the first entry that contains the same hash code. And after that, the next entry that have the same hash code, like here you can see in the 7 and 11 index. But how we are going to differentiate whether our two entries are equal or not? We cannot just differentiate between using their hash code value. As you can see here, hash code can be equal, but we can just differentiate using our equals method. So there are two methods, first of all hash code and then equals. If we, in any case, if two objects have the different hash code, then we know that they cannot be equal. But there is a possibility that if two objects have the same hash code, then it can be equal or it can be not. So first of all, we are going to implement the hash code method, and we are going to place any object at any particular index, and at any index we can have multiple objects, so we are going to differentiate them with using the equals method. So hash code will be used to place any object at any particular index inside of our hash table. Like if any object have a 0 hash code, then we are going to place it at 0 index. Okay. Suppose for our example, if we have 5 and 25 as our objects, so these are our integer objects. And suppose we are implementing a hash code method that just uses modulo 5. So this is a very poor hash code method that we will be using here. So 5 modulo 5 will be 0, and 25 modulo 5 will be also 0. So as you can see here, hash code of these two different values are equal. So 5 and 25 are two different values, but our hash code method, that means this modulo 5, return us 0 for both the values. So we are going to store this 5 and 25 both at 0 index. So we have to implement a unique, or we can say a optimized hash code method, so that we can have unique hash code for our entries. And here you can see 5 and 25 are two different objects, but how can we differentiate whether they are equal or not? Using our equals method. So we are gonna also implement our equals method, so that we can just differentiate between two objects. So like here you can see, we are gonna implement this. There will be our head object, and we are gonna store our whole entry inside of our linked list. So first of all 5 and then 25. So these are now two different entries, and we can just differentiate between them using our equals method. So that is the use of our hash code and equals method. So let me just show you how we can override the hash code and equals method to make our pair unique. So first of all, let me also create here one more pair object. So pair 2, as you can see, this first pair and second pair both have the same a and s values, that means name and number. So let me just print whether this pair 1 is equal to pair 2 or not. As you can see, both of these pair objects have the same value, but they will be not equal, because their hash code and equals method is not overridden, and by default they will be at different places, so they are not equal. As you can see, they are not equal because they both have the different memory location. So let me also show you that. Also for our pair 2. So this will just return us the memory address of our objects. As you can see here. So first of all, this is our package name, and after that our class, and here is our unique memory address. So they both have the different memory address, and that will be defined using our hash code and equals. So we have these memory addresses, and using the double equals to, we cannot find whether the both objects are equal or not. So instead of using here double equals to, let me just use here equals method, like we have to do in our strings. So you know that we can compare two string values, two string objects using this dot equals method, because this dot equals is overridden for our string classes. This time again you can see we are returning false, because the equals method is not overridden for our pair class. So let me just override. So here we have to use this override annotation, that will just ensure us we are overriding a method. So equals, and here we have to take our object. So here we have to take our object, okay, and this should be a public method. Either you can just implement it like this, or you can just press on alt and insert, and here you can just see. So we can override our hash code and equals. So this time we are gonna only override equals. So here we have to compare both the pairs using their number. So here you can see this first pair also have 1 and second also have 1, and we are going to use here number, compare both our pair objects. So first of all this, that means we are accessing this current object, this current pair object. And I hope you already know how we can use this object. So object dot number, okay, this is a object type. So first of all we have to typecast it into a pair object, okay. So here we are gonna use this assertion. So this can be a new keyword for you, but it is very simple. We have to just assert that this object is equal to our pair object, and only then we have to do something. So assert this object is an instance of our pair object, okay, this pair class. So now we know that this obj is now a pair object, okay. Now you can just use this num. So here we can just click, and it will automatically typecast it. So either you can just do it like this, or you can directly create a pair object. So when this dot number equal to our object dot number, and we have to also compare these string values. So this dot name dot equals our object dot name. So when this number and name of both the object pairs are equal, both the pair objects are equal, then we are going to return true, else false. So that means these both objects will be equal now. So using this equals method, we are going to return true, as you can see here. But still, so this is our equals method, but still they both have the different hash code. So this now this time it is a problem. They both are equal, but they both have the different hash code. So that can cause a problem. If you are overriding our equals method, then they definitely have a same hash code. So you have to remember that thing. If and let me create a map. So you have to remember this thing. If two objects are equal, then they must have the same hash code, and so you have to always override the hash code method when you are overriding our equals method. So map dot, first of all this value and our second value. So let me just show you that both of these objects are still different, because they will both have different entries inside of our map. But still here you can see these both pairs are equal, but they will have different entries inside of our map, because we are not implementing its hash code method. So we have to also override our hash code when we are overriding equals method. So let me just try to print the map, and as you can see here, there are two different entries inside of our map, because our still hash code method is not overridden. So suppose the hash code of our first pair is like this, and the second is like this. So they both are equal, but they both have the different hash code. So for solving this problem, we have to also override our hash code method. So you can just override it from here. So here we have to also check for our base cases when we are overriding this equals and hash code method, that our object can be null, our object can be also equal. So instead of just doing it manually, you can just press on Alt and insert, and you can just use this hash code and equals. So just click on next and next. So here it will automatically generate all the methods that with all the base cases. So here is our equals method with this base case, and this can be also equal, and this can be also null, and they can be also from our different class. So it will just check for all the base cases, and our hash code method is also overridden here. Here you can see, so it will just get a method from our objects class. So now this time both of these pair objects will have the same hash code value, and they will be also equal, because we are implementing the hash code with the same parameters, with the same members. As you can see here, now they both have the same hash code and they are both equal. So I hope now you understand the use of this hash code and equals method. And let me also show you with the map example. So this time they will only have one entry inside of our map. As you can see. So after this, let me also show you what is a set. So set is nothing but it is just a wrapper around our hash map. It internally using our set. So set of integer, and let me just create a hash set. So hash set is something just like our hash map. So we can just add unique values inside of our set. So set dot add our integer value, and it will definitely have our unique values. Here you can see our set only have unique values 1 and 2, and after that it also doesn't support any order. So if we are using our hash set, so I am adding here 3, 4. So it will just not store the order if we are using just normal hash set. Like our hash map, it will not store the order. Here you can see. Okay, it is storing the order. Let me just add more values. Here you can see, first of all we are adding 6, and after that 1, 2, 3, 4, 5, but it is storing in different order. Okay, so after this we also have our linked hash set that will just sustain the order. So it will just print these values in the same order, 6 and then 1 to 5. Here you can see the same order, and after that we also have our tree set. So tree set that will store values in a sorted order. So if I am adding values like this, then it will just sort all the values. And it is nothing different. It is internally using the same concept of our hashing. And let me just show you the internal working of our hash set. So here you can see inside of our hash set constructor, we have this map. So inside of our hash set, we are using this map object, and this is of same type, and we are just passing any random value. And here you can see we are just passing a present object value. Okay, so there is nothing value inside of this, and all these are considered as our key of hash map. So this is nothing different from our hash map. Okay, so it is a wrapper around it. I hope now you understand the concept of this map, set, and this hash code and equals. So I hope you learned something new from this video. So don't forget to like it and also subscribe to our channel if you want such content. So thank you for watching.